Hey everyone, thank you so much for joining and for being patient. Um, very excited to be here. My name is Jeremy. I'm leading this operation at Hyperbolic. Um, and focusing around the partnerships, focusing also around policy execution. If there's any interest to build interesting partnerships together, please come my way later on. I would love to meet all of you. And wanted to also pass the mic to Ali for a quick, introduction of himself, and we'll give you a little more context of everything that I've been working on in the past with guys, specifically the radio theory, and integration. So I'll leave that to him, and we can, start it.
Hey everybody, I'm Ali. I'm part of the video team at Hugging Face. What I want to talk about today is the Radio Playground, which is an AI program that we have on our website that helps users quickly learn how to use radio. Um, and we use Hyperbolic for it. So I'll go over what radio is. I'm not sure how many people here are familiar with it, and why we decided we wanted to build the playground and how we built it. Okay, so Gradio, the GIFs are not working, doesn't matter. Um, Gradio is a framework that lets you build and share machine learning apps. So what does that look like? If you were to do this without Gradio, this might be your setup. First step might be that you prototype with the machine learning model or whatever pipeline you're using, but essentially getting to the Python function that generates response given an input. But if you wanted to share this, you wanted people to use it, obviously have to wrap it in some sort of a UI, which would mean you have to write some content. If you wanted to scale it, you might need to containerize or deploy, um, create some endpoints for it, and write documentation for those endpoints, and create some type of analytics setup, etc. And so that's where Radio comes in. All you have to do with Radio is just the Python work related to the model itself. And we'll take care of everything else. We'll wrap in the UI that can handle images and video and audio. Um, it'll be scalable. You can set up queues and do all sorts of things. It'll come with API endpoints that are already documented. You can see analytics for it as well. We've had a lot of usage over the past few years. We have over 6 million monthly downloads now on PyPy. We have about 500,000 grading apps on Hugging Face basis. But over time, the radio ecosystem itself has gotten large. We're not just a Python library anymore. We also have the clients, JavaScript and Python. We have the components, Radio Lite, which is a serverless version of Radio. We have a ton of integrations, some Hyperbolic and so on. And so it has been a challenge to keep Radio accessible and easy to learn over time. This is a screenshot of our docs. I think our docs are great. I'm a little bit biased because I wrote most of them, but I think they're fantastic. The only problem is that no one's reading them, or at least not like they used to. And this is obviously a bit of a dramatization, but nowadays more and more developers are relying on LLMs to learn how to use a new library. And that's fine, except that they're generating a lot of errors specifically with grading. And there's a lot of reasons for this. Maybe it's like a, can you guys still hear me? Hello? Can you hear me? There are a lot of reasons for this. Maybe it's not cutoff thing and like using old deprecated syntax. Or maybe it's like some niche radio feature that the LLM hasn't seen. Or maybe our fantastic dogs are not LLM friendly or scraper friendly or whatever it is. Um, there's definitely a gap. But in this example, for example, this is a bit of a niche feature. It's custom CSS in Gradio. Um, but obviously Cloud got it wrong and the buttons are not red. Um, and to its credit, it got most of the code correct, but it just it picked a CSS selector that doesn't actually exist. So that's why we built the playground. Um, we kind of wanted to space that's authoritative on radio that users can use to kind of learn how to fill this gap for them that the regular LLMs are not going to be able to fill. Now, I should say two things. First, that there's nothing really super sophisticated about this setup. This is more of a first approach. And actually, the point of the talk is to just show you how far you can go without a very sophisticated approach. And the second thing is that we're not trying to create a code generator that can build full, like, complex apps without any errors. The point is to get the gradient part right. Like, this is more or less documentation. So this is why we decided to build it. How did we build it? Well, the first decision was to decide on which LLM to use. And over time, a lot of open source models have really started to bridge the gap in performance with closed source. You have a lot of options now, and Llama and so forth. I didn't really use this benchmark, if I'm honest. I mostly just experimented and tried a bunch of models with my system prompt and tried to see which one would search the most. I did use this benchmark, and it's no surprise, but open source models are obviously significantly cheaper to use, and that matters a lot to us just because our first approach was to have this gigantic system prompt that has a very kind of exhaustive view of video. And so it was going to cost a lot if we use the open source model. And this is what the system prompt looks like. It starts off with some simple instructions, and then it just dumps a huge amount of demos that you already have on how to use, like, X radio feature. And there's a few interesting things. One interesting thing that I discovered was that the LLM still make mistakes on the gradient syntax. For example, we have some listeners, and it's seen them in a few of the demos, and depending on how the user phrases the question, it might guess that this other listener must also exist. And if we're serious about using this as a documentation tool, then it really can't make like a mistake with gradient syntax. It's fine to get the non-gradient part incorrect, but the gradient part should be correct. And so one thing that helped a ton was that I just dumped all of the classic function signatures in the gradient library. And even without describing even without describing them or even showing like examples of them, just the function signature is enough to ground the model into actually correct gradient syntax. So if you want to like write something that doesn't even exist in Q. But it's still made some mistakes. Quite very chose when we found it was the best at like instructional problem. But this is very like quantitative assessment. It was just the best at what I tried it for. Oh, okay. But there were still quite a bit of mistakes, and so what we did was we compensated for those mistakes in the UI. So the first decision we made was to use Gradio Live. I think I can probably do this without the microphone. Yeah. Okay. Stepping in and out. And Gradio Live essentially is a version of Gradio that runs entirely on the browser. And this does two things. The first one is pretty obvious. It shows the user what the app looks like, and so they can see like when it changes in the code or they edit the code, how the app will look different, which is obviously a big plus if you're trying to someone very good have you in your library. But the second thing is that the quicker previews just make things so much more forgiving these days. So instead of going to your Claude and asking the question, taking the code, and then putting it in the editor and running the radio app for it to launch, and then seeing it fail, which can be very frustrating. Here they can just like ask again or pass the error or whatever. The second thing we did was we have it. These are all just guys, but it's okay. The second thing we did is that we have it updated the code on the editor instead of all making it from scratch. And if you already have like kind of a structured code there, it makes the LLM much less likely to make a mistake or get confused with your request. And then on the navbar on the left, you see we have a ton of like starter demos that are like a good place to start, depending on what the user is looking for. So this had like a massive effect on accuracy. And the one thing we launched very recently is this is the first kind of agentic thing we've done, which is we feed the errors back in and regenerate the response. Um, so what this video is going to show is that there's a it adds an image component, but it forgets to add like another parameter to the Python function, which will now have two inputs and not just one. And so we can capture the error in the preview and immediately just pass back. And we got this idea from our users. A lot of people do this with LLMs now, they'll just copy paste the error. Even without context, LLMs are pretty good at like fixing the problem with just the error. And so we just do that for them. Anyway, we have some decent usage, but there's really a lot of room to grow here. We've gotten a lot of ideas from this experiment. And like we've thought about where else in the radio ecosystem there's space for like an AI feature that can help people move faster and learn faster. Um, but the idea is that now we can do a much more sophisticated approach, especially using all of the prompts that we've collected, and just have a much more sophisticated pipeline. That's all. I don't know if anybody has any questions.
Is there be like a framework built to like streamline this kind of all APIs?
That's a good question. What do you mean by APIs?
Like, so this is like this will teach you how to like use the Grader API. Let's say like if you have like another API that you want to learn how to use and you want to like use it in an interface that's similar to like this instead of like reading the docs, can you be able to pass that API into like some service or like some framework that can be built and have the same process?
Yeah, that's a very, very good idea. Actually, we did, so this is what the playground looks like, and with Radio Light, we actually have, um, we created this attribute called Playground that essentially puts a code editor side by side with like a preview. But this is like very, this is obviously custom built for radio itself. Um, but, but yeah, someone should build, I would definitely use it. Yeah.
Um, I had a question about, I guess, like the journey of radio, and I guess how you or your co-founders got the idea, and what it was like getting acquired. How you realized this? I mean, I'm a big fan, but I only found out about it like 2 years ago, so you were way ahead. But, impressive.
Yeah. So we started radio in 2019, kind of the ancient era of machine learning. And it started as a collaboration tool. It was part of a lab at Stanford between machine learning researchers and the medical school at Stanford. Um, but the problem back then, which I think still exists today, is that a lot of machine learning researchers love Python and can like love interacting with machine learning model, but they hate writing content code. And so this just makes it a lot faster for you to demo um, your model without like spending a ton of time learning tech that you might not want to learn. And I think like the fact that we were early helped us a lot because in those first few years, there were just like so many demos that were. I mean, this is still the case like today, but before the giant LLMs sort of took over, there was just a ton of like every week there would be like 20 important papers and people really wanted to be able to share them and like share the code and share what they did. And so a lot of people ended up using Radio. When Hugging Face launched Spaces, that's when we started working very closely with them on Spaces because they wanted to use time. That kind of led to the acquisition. Yeah, you're welcome.
Any? Yeah.
In the reflective process, you have error and the reflective give it back. I think there is some other company like launching, I think also replicate, they all work on the similar thing. May I ask know what's your specific, because I think I use replicate. I think it can build a UI and front end and back end all together. What's the difference between Gradio with replicate, for example, on the reflective process?
Good question. So Replicate focuses mostly on, if I understand it correctly, but mostly on the API endpoint, kind of containerizing a model and making it easily accessible by a lot of people. And Gradio focuses more on the UI side of things. I haven't used Replicate that much, but I think that the Gradio UI portion is just much more extensive.
I think
If I understood the question.
I think yeah, it's my question, but I think you also mentioned you can do other things like deploy the model
Yeah.
altogether. Is there a reason why for example, I currently use Replicate a lot. A reason for me to change from Replicate to Gradio? Because
yeah. Yeah. Okay. So I think that it depends a little bit on your use case. If you're building something just as a demo, you'll get there a lot faster with Gradio. You don't even need to host it anywhere. Like Gradio has like a shared link that can get generated in just like one line of code, and it's still running on your laptop, but people will get an actual URL they can use. If you want to deploy it permanently and like pay for compute and all those things, then probably Replicate makes more sense.
I think it's really useful, and I want you to spend more time on the code development of TRL package in the future.
Awesome. Yeah, thank you. That's all. Awesome, thank you.
Do I need to make an intro?
Yeah.
Thank you so much, Ali. That was an amazing, amazing presentation. So without further ado, would love to introduce you to the CEO and co-founder of Hyperbolic, Jasper Zhang. So I think Jasper has a couple of things he wanted to share with you, so I'll leave it up to you.
Yeah, thanks for the intro, Jeremy. Nice meeting you guys. I'm Jasper. I'm the CEO and co-founder of Hyperbolic. So before starting the presentation, probably I should do a little bit background. So I did my math PhD at UC Berkeley. I finished it in 2 years, which made me the fastest person to finish a PhD in the history of Berkeley. Before that, I did my undergrad at Peking University, graduated with the highest honor, and I also won a few gold medals in different math competitions. Before I founded Hyperbolic, I work at Avalabs and Citadel Securities. So I founded Hyperbolics by the end of 2022. I got a co-founder, Yu Chen, who did his CS PhD at University of Washington. He did AI system and networking research. After that, he joined an AI company called Octo AI, which was acquired by NVIDIA, that building an open source AI compiler called Apache TVM, which is a compiler that can compile different AI models on various hardware backend like AMD, NVIDIA, Intel, etc.
And so we are now like a team of around 15. We raised 3 rounds so far, got 20 million in the bank, and we're going to democratize AI for everyone here. We got a lineup of advisors. Renat Singh is the co-founder of Databricks. We also got a few professors as advisors, like Professor Raluca Adepapa from UC Berkeley, Siamat from Columbia, and Professor Ima from Hong Kong University and UC Berkeley. And so our mission is that we want to democratizing AI innovation, and we also want to accelerate AI evolution for everyone. So we believe that AI will integrate with everything in the future, like social media, transportation, robotics, finance, even your brains. And right now, in these like centralized environments, all these big companies are building AI, while there are many talented researchers and developers are struggling with getting access to enough compute to do the research. And we see like, okay, there is a Stanford postdoc who's my friend. Like, he created a new idea about test time training, but then he was struggling getting access to compute, and then ending up joining a big company, Meta and NVIDIA, to try to get access. And they're also like startup trying to do AI training, but then was lack of compute, and they could not do it. And so we at Hyperbolic, we try to say, okay, right now there are many people that have crazy ideas to change the world, but the barrier is not what their capabilities what their capabilities are, but instead it's just the lack of compute. So if we can actually gather enough compute for them, then actually we can remove the barrier, and then we can make sure that all this AI innovation can happen not just in those big centralized companies, but it can be in startups, in schools, or just at your home. So we look at the world and we realize that although many people are struggling with getting access to compute, there are also a lot of computing resources that are underutilized. And so there are more than 2 billion computers around the world, and then half of them are just sit idle for more than 19 hours a day. And let's say after Ethereum shifted to proof of stake, after from proof of work, there are equivalent of 10 million RTX 3090 GPUs are sitting idle. And let alone there are many new data centers that are purchasing H100s and A100s, those advanced GPUs, but they're struggling with getting access, getting like buyers to use their compute. And so what we want to build is that if we can actually gather the world compute resources, we can actually have 50x more than compute that is being used for a leading foundation model like GPT-4. And so what we are solving right now, we have 3 goals. First, we want to utilize decentralized heterogeneous compute. What does it mean? It means that first, we want to build this decentralized orchestration layer that can aggregate global GPU resources. So we invented a new technology called Hyperbolic Decentralized Operating System. So long as your machine, whether it's like MacBook or like a server like H100, you just need to download and install the operating system within 1 minute. And then after that, your machine become a node in our network. And everything is built on top of Kubernetes. So if you are an engineer who are familiar with Kubernetes, or even you just need SSH into the machine, you can easily orchestrate all these GPU resources across the world. And on top of that, we're also building some services that provide serverless APIs to developers if they don't want to just access the raw machine. So we built this Hyperbolic compiling service that can compile different AI models to run on any kinds of GPUs, including NVIDIA GPUs, AMD GPUs, Apple GPU, Intel GPUs. And we achieved some amazing performance on AMD GPUs recently compared to some popular serving framework. So we kind of, right now, our inference service has been up for 8 months. And I think we're one of the popular AI service in the world. We integrate with Hugging Face, we integrate with Quora, who we're gonna present soon, and we also is one of the providers on OpenRouter. And every day we have more than 2 billion LM tokens processed. And even OpenAI co-founder Andrew Karpathy mentioned that he's using Hyperbolic for his research. And so if you are an AI app builder, whether you are building just normal AI app using LMs, or you are trying to build some AI agent, feel free to talk to me, or just go to our website, app.hyperbolic.xyz, and then use the APIs for your applications. Then the second thing that we're trying to solve is that once you have machines contributing across the world, you need to solve the trust problem, because now these machines are not controlled by you, it's controlled by a random third party. So you need to design a verification mechanism to make sure that the nodes are actually running the program that you want them to run it. And so what we designed is called proof of sampling. So it's like a sampling-based verification mechanism. So instead of checking all the results generated by one node, you randomly sample some of the results from a node. And then if one of the results is found out to be wrong, then you will slash the node with a high amount of penalty. And it's just like, I can take a simple example first. So for example, if you go to a bus, you want to take a bus in Switzerland, they have a very interesting ticket system. So most of the cases, you just buy the ticket and jump on the bus. No one will check your ticket. But then there's some chance that an inspector will jump on the bus and ask you to show the ticket. If you doesn't have the ticket, they will charge you for $100. However, the bus ticket only costs you $2. So as long as the chance of checking is high enough, then as a rational person, then you will think that, okay, I should buy the ticket all the times. Otherwise, the average I need to pay is actually higher if I skip the tickets. And so the same idea here, and by running some math analysis, we can prove that the system has a pure strategy Nash equivalent, which means that every node in the network, the best strategy for them is to behave honestly all the time. And so this is the design that we have, and we're going to ship this very, very soon. And lastly, what we want to do is that we want to protect users' privacy, even it's run on the random third-party node. And so we're exploring the solution TEE to protect users' data, and so long it's running inside the TEE machine, then users' data are protected. And so I would say this is just the start of building this open AI ecosystem. We know that compute is the foundation for all these AI services, AI models, and AI agents. But it's just a beginning. We're going to see more and more developers implement their own services on Hyperbolic, because we are this permissionless Kubernetes framework that allow users to deploy their own services. And then we're also going to see more and more AI agents and AI models running on Hyperbolic, either power some traditional Web2 apps, or even behave as an AI agents to execute transactions and operations on behalf of human. And besides, so I think in order to show, I want to show you a quick demo to show you a fun experiment that we do on Hyperbolic. So everyone knows AI agent is very popular right now, and the way I see AI agent is that it's an AI program that can transact or doing operations on behalf of human. And a crazy idea that we have is what if an AI agent can actually access the compute on Hyperbolic, and to AI agent, the compute to AI agent is actually food to human. And so that will kind of lead to a lot of crazy experiments afterwards. And so we built a very easy demo using LangChain. And so I'm going to show you, due to the technical limitation, I can just show you the recording, but I can try to expand that on the side. So what it's doing is that, okay, now as a user, first I want to know how many, I want to know all the available GPUs on Hyperbolic. And so what the agent is doing is that it understands my question, and then it can call the API of Hyperbolic to find out all the available GPUs, and then it will process the JSON response, and then parse it, and then know what kind of GPUs it has. And so as a user, I would say, okay, help me to rent the first GPU, because I think that's the cheapest one. So it would call the API again, and then it will successfully rent the GPU. And I will say, okay, help me to check the status of this GPU and see if now I can get the SSH command. And so it run the API, and then it will find out, okay, the SSH command here is the SSH Ubuntu, and then add like this thing. And so I would say, help me to connect to the GPU. So we build a tool for it to actually access the remote machine. So you can see it successfully connect to the GPU. And now, just as a simple example, I want to ask it to execute commands. So just say, okay, help me to check, like maybe say like just help me to check like GPU, how many GPUs it has by running like NVIDIA SMI. And we can see how it goes. So you can see it actually run the NVIDIA SMI command and then figure out the machine configuration. And so what I want to say is like this is just a simple step, a simple experiment to show how AI agents can actually work with compute platform. We see many potentials here. First, it kind of changed the UI UX experience of like traditional cloud platform, because instead of just like what you usually do on AWS, like you need to go to the EC2 page, you need to set up all this configuration and like launch an instance. You can actually just have an AI agent that control the whole compute platform, and you just by talking to it, you can rent the GPU that you want, and even besides that, it can also set up the environment for you. So basically, you have a DevOps agent, right? And then even crazy idea is that the AI agent is running on compute, right? And so if AI agent can rent compute, it means first AI agent will be able to self-replicate itself. So it can rent 100 computers on Hyperbolic and then just like run some different AI models or just the same AI models of itself. And it can also try to self-evolve itself because it can use compute to do fine-tuning. And I mean, this probably sounds futuristic, but maybe in 2 years we will see that happen. It can even just like run a consensus between all these different clones. So let's say I'm an AI agent, I rent 100 compute and then I launch 100 clones of myself on Hyperbolic. And then I just run a consensus or like a messaging protocol to update the knowledge. So all these different clones have this consistent memory. Then even 99 clones or replicas of the AI agent is done, or like even 99 machine are done, then at least you have one machine that store the memory, and basically you have an AI agent that can never die. And so I would say like the mission of Hyperbolic, when I talk about like we try to first democratize AI innovation and then accelerate AI evolution, the second part is actually not about human builders. It's actually about for AI agents. And if we think that AGI will come in the next 2 to 3 years, and then we'll also have autonomous ASI in even like in the near future, then
we need to think about how to build an environment so that those AI agents can freely grow and develop themselves. And I would say we don't want only OpenAI and Anthropic to control those AI agents, and we want everyone to have the power or permission to build and grow their AI agents. And so, yeah, that's the purpose of Hyperbolic. Thanks.
So thank you for the presentation. So I remember that you showed a very impressive, performance compare between your inference service versus the most up-to-date VLM, package. So I was wondering, because you showed that this is done on a AMD series, GPU series. So I'm not sure in terms of like NVIDIA GPUs, do you have any advantages, in terms of the runtime performance over other, inference platforms?
Yeah, so I would say NVIDIA, VLM and SGLang, like NVIDIA machines are the most popular machines, so they're fully optimized for the machines. So I would say mostly they're not much performance difference, and yeah, and I would say recommend using SGLang and VLM. And, yeah.
Got you.
Hi. So for the API service you provide, is it running on the centralized cluster or the decentralized cluster you just mentioned?
Yeah. So the API, you mean like when you want to rent the GPU?
Yeah. When
Yeah.
I use Hyperbolic API, is it running on the decentralized cluster or it's actually a centralized one?
Sorry. Let me show you the. Okay. Maybe I'll just answer it. So So I would say the gateway is centralized at the moment, but then like we have compute provided by different data centers. And then we're gonna open the gate to individuals, and it will become like a fully decentralized compute network.
I see. And another question is that for different kind of GPU, because a lot of distributed inference or training algorithm actually assume that the GPU type are the same.
Yeah.
But how to make it work on different GPUs type?
Yeah. So I'd say for inference, because now most AI models can run on just one machine. And so what we're doing is more about like distribute
Load balancing.
Yeah, load balancing things. So that actually is easy. For decentralized training, I think it's still a long way to go. There are some companies that are working on decentralized training, like News Research, like Prime Intellect, etc. And I would say like once they figure out the solution, they can easily deploy the decentralized training service on Hyperbolic.
Okay.
Yeah,
Okay.
because
Thank
we're
you.
like Kubernetes
Yeah. Thank you.
platform. Thanks.
May I ask, can you give me an estimate how much money I can save if I use Hyperbolic compared with Amazon SageMaker?
Yeah, so I'll say H100 now on our platform, like the cheapest price is $0.99 per hour on demand. And I think on AWS, it's like $5 to $10. And so, yeah.
It saves a lot. Thank
Yeah, thanks.
Hey, Jasper.
Hey.
Huge fan of your mathematical achievement. And as a few of us, mathematics is the highest form of abstraction or intelligence that, so it's slightly different from your work, but I want to know in terms of the current state of the transformer LLM architecture. I mean, it's just a bit of matrix manipulation. Instead of that, have you researched on, or have you thought about how you could use like topological invariants on neural networks to achieve a better level of intelligence on AI? Something on that.
Yeah.
And side question, will the current architecture achieve AGI, true AGI?
Yeah. So the first question is like whether I thought about using topological structure to create a new structure for LMs and AI. I think I thought about that, but I didn't have enough time to actually do research because I was busy building Hyperbolic to get enough compute. But I think maybe in 1 or 2 years, once we have like thousands or millions of H100s, then I can start doing more like fundamentals architecture research. I think a lot of I just recently watched a video like at a AI conference that like someone talk about using topological structure to redesign transformer. I think probably that will and make some people also trying to use like hyperbolic geometric embedding to do like to improve transformer. So I'm trying to learn from that and try to see if I can contribute anything. I would say currently the transformer structure probably is not good enough for us to lead to the AGI because the transformer is only good at like generating languages stuff, but when it comes to reasoning, especially like logical reasoning, like math, I don't see it will achieve like 100% accuracy. And so there are some people trying to improve that. And I found out that like the Sakana team recently they released a new structure called transformer square, which can adaptively change the structure of transformer. I found it very interesting, and I think that we'll see more and more like this research coming up in the future.
So I'm curious how you're connecting crypto into this, because you've got, or payment processing. So I have a GPU consumer. You mentioned paying in US dollars, but I can imagine I could be able to pay in Bitcoin or whatever cryptocurrency you might have, because I have distributed AI and distributed compute. And if I'm going to pay, say, $10, and you need to somehow pay the GPU provider $10 minus your cut, and you know it's happening around the world. How are you handling the payment processing, and have you considered adding a token to your system?
Yeah, so we actually are thinking about it. I think the token piece is helpful. First, if like the traditional financial like payment system is actually broken. Like if you are like for US it's good, but then for other countries, it's actually the banking system it's really hard for you to get enough compute. So our platform also supports crypto payment, and then we also see crypto as a way to subsidize and start the flywheel. Because if you think about the Uber case, at the beginning they need to compensate both riders and drivers with cash, but then in our ecosystem there's a way for us to actually compensate the compute providers with token, and then that will also help them to enjoy the growth of the ecosystem. And another conjecture or like expectation we'll have is that we'll have more and more AI agents, and it's really hard to get a credit card for AI agent. So then crypto rail or crypto payment will be the way for them to get enough, get access to compute. Yeah. Okay. One last question then, I guess. Oh, two. Yeah, I think.
Thanks for taking the question. So at the moment, we use H100 GPUs on GCP, specifically the A3 Mega, which has 1.3 terabits per second inter-node communication speed. So I wanted to ask this question. I tried to check on the website as well, Hyperbolic Labs. I couldn't find what's the inter-node communication, so that during distributed training, GPUs don't idle out, or do you, if yes, if you have this optimization in some way, could you maybe share something about that?
You mean like inter-machine communication?
Yeah, inter-node. Each node has 8 GPUs, and
Yeah.
we use around 60 GPUs in one training run. And
Yeah.
So how do you do that?
Yeah, so on our platform, right now, we only support single node rental. So in that case, you don't need to worry, we don't have the inter-machine communication. But then soon enough, we will support cluster rental. So in that case, most of the machines on our platform, the cluster are like infinite band connection. So I think the speed should be high enough for you to do distributed training. So it'll be ready in 2 months. Yeah. One last question. Yeah.
For your talk, have you heard of BitTensor?
Yeah.
Yeah, so I'm just kind of curious. I use BitTensor. They have a limit of like 256 compute providers per network. And I'm kind of wondering, so what it sounded like was that you're trying to make it like unlimited, or how are you trying to differentiate yourself? And also, how is it going to scale?
Yeah, so I would say BitTensor is more like a token play, while we're more like an AI infrastructure play. Our system and our infrastructure is designed to handle millions or even billions of computers or like nodes in our network. So as long as you have the compute, we should be able to connect your compute to our network and let it be used by other people.
Gotcha. Okay, thank you.
Yeah, thanks. Thank you, everyone. And yeah.
Thank you very much, Jasper. That was an amazing presentation. I would like to welcome Cheyenne Zhao from LMSYS. So we'll just have a yeah. No, it's the other one. Yeah, it's here.
Oh, take it back. Not this one.
Yeah, this one.
Yeah. And I need to use the present mode. I mean, this is only one. You know, since I need to see, I need to see. I can try to do that. Okay. Okay. Okay, hello everyone. Yeah, Jasper has made a good example of presentation, right? We should make a self-introduction before the presentation. So my name is Chen Yang, and I was born in Tibet, and I grew up in a small town called Negeva. In Tibetan language, that was called a place with burgeoning fire, right? And today, I really come from a place with burgeoning fire. I come from Los Angeles, and the wildfire even burning at the boundary of my house. And I have to take my cat with myself to San Francisco. And San Francisco welcomes myself, right? It gives me terrible traffic. It takes me 4 hours from the airport to right here the place, right? So it takes me really a long way come here, and I come from a place with burgeoning fire. I hope you guys will remember that, and we think we are at the place or the air of burgeoning AI rise. So my name is Chen Yang, and I'm a PhD student at UCLA, and I'm also working in the LMSYS organ, and hope you will enjoy today's party. So what's my topic today? I'd like to introduce our inference engine. We call that SGLearn, right? SGLearn is not a language, it's an inference engine. So think about what is an engine. How should we define an engine? So today we got to go over these 4 parts. I think you got to get some overview of what we have done for SGLearn. The first part, SGLearn's overview, and second, several remarkable milestones, and the third, leading features. We have 4 features to introduce today, but I will just cover 2 of them, and later 2 will be discovered by Byron and by Ke online, right? And the last part, we'll discover our open source roadmap, and hope you enjoy this. Okay, so let's begin. SGLearn is the fast serving engine for large language models and vision language models. We have launched this project for over 1 year, and it has gained nearly 10,000 GitHub stars right now. And among all the fully open source LM inference engines, SGLearn currently achieved the sort-type performance. And in the meantime, its elegant and lightweight and customizable design has attracted wide adoption from academics, big tech companies, and startups. And also, I think by a lot of self-developers, they also love our project. And we really enjoy today's chance to share our project right now. Okay, so, okay. SGLang team is incubated by LMSYS organ, and we have an amazing team with more than 10 main chief contributors. They are continue to committing into our project, and some of our crew members even make commits within their wedding, right? So we have a team member. He come back. He go to Taiwan for his wedding, but he's continued to contribute. So our team is really excited and building open source projects, right? And we have more than 200 contributors, and hope you guys, someone has interest in that, will contribute to us. And today we also like to say special acknowledgement to Hyperbolic. It's the first organization who give us support for GPU and for a lot of things, and to make out to our place. And thanks so much for Hyperbolic and for today's chance to sharing, right? And also we have some sponsors, right? NVIDIA and AMD A16Z and RunPod and Data Trunk, Gems and T Studio and Basin. Okay, so let's go to the second place. Some remarkable milestones. So I like to go over this. Like first, we launched our project and maybe 2 years before and the late 2023. This is our initial motivation. We have structured language model programming, and we have prefix catching and constraint decoding. And later, maybe half a year later, we have leading the performance among inference engines on Llama 3 models. And right now, we think we are still the best serving engine for Llama 3 models and DeepSeek models and so on. And later in 2024 September, we have our 0.3 version released. We are the best DeepSeek model server, and we are better and Torch compile, and we also support multimodality models. And later to the December, we have launched our 0.4 release. We have zero overhead bash scheduler, and I will cover that today. And we have cache-aware DP router, and that will be discussed by Byron today. And we also have XGramma integration. It's even sort of performed grammar backend for constraint decoding. And we are the first one to serve DeepSeek v3 model, and that's really somehow like a silver bullet to us. And as you know, SGLang has been extensively adopted and served as the dominant inference engine for AMD, and we are the default choice for XAI. So we hope you will also choose our project. Yeah, that's it. So let's take a step forward. Today, as I've discussed, we will cover 4 leading features. I was just discussing the first 2 and the last 2 will be discussed later. So the first thing regarding zero overhead bash scheduler. Let's first look at this picture, right? It demonstrates some basic usage of our SGLang engine. You see, somehow the pink one is a scheduler. It's running on CPU. It's somehow like doing tokenization, detokenization, and communication between lots of components, right? This kind of thing should be done on CPU. And on the other part, we have model worker. That's on GPU. You have to do forward, you have to do sampling, this kind of thing, and that should be run on GPU. So traditionally speaking, most of the time for the serving engines, we run the GPU and CPU in a synchronized way. I mean, CPU do the tokenization and send that to GPU, and GPU do forwarding and send it back to CPU. So in this way, you can see it's a blocking method for serving. And if you process some extremely long sequence, the tokenization will take a lot of time, and it's blocking a lot of things, right? So and our latest version, we have released the overlapping version of scheduler. The idea is that we want to overlap most of the CPU computing together with our GPU computing. So this time it is non-blocking, and it gets much more quicker. And we are proud to say, what's wrong with this? We are proud to say, after doing profiling, we proved that overlapping SGLang version has squeezed the last performance of our GPU and CPU. So that's the fast way, and we are the best to do this kind of overlapping. Right now, a lot of people may know that it's hard for serving engines to do generalizable speed up for any model, but this kind of overlapping could do something at this scale, right? We can speed up any model with overlapping serving engine for somehow like 2 times better. That's all right. So, and if you want to know more in-depth in details, you can see our talk on GPU mod. Yeah, and the second one today I'd like to discuss is about X grammar. As you may know, sklearn has been the fastest engine for constraint decoding. Constraint decoding is like something like the JSON decoding, like you want to do somehow like do using eBNF to do decoding night. A lot of people doing your agents and you want it to answer in appropriate format, so that we need constraint decoding. But traditionally speaking, constraint decoding takes a lot of time since you want to maybe filter through the whole like the vocabulary, and llama vocabulary is pretty large and it will take a lot of time. So right now we have integrated the fastest grammar backend. We call that X grammar, and we use these kinds of optimization. The first one is the context expansion. Like we try to understand nearly most of the context independent grammar from our grammar, and to make that pre-cached, and we do not need to compute that again. And the second thing is the persistent execution stack. Like when you are doing JSON decoding, you have to maintain a stack like a tree, and to go over and to go back forth and go forward. Well, every time you are moving in this tree, you do not need to copy the tree, but just moving and the trace each node. So it will save a lot of time to avoid splitting and copying your whole stack. And the second and third thing, we are optimizing our push down automat structure. This comes from our compiler, right? In compile series, we have these kinds of optimization, right? Like the push down automat structure, and we are using something like inline and equivalent stage merging to make it even faster. And lastly, we have parallelized grammar compiling. That means we fully utilize all the CPUs to compile our grammars on each CPU core rather than just running it on one CPU. So together with all of these kinds of technology, we take sklearn plus with X grammar to be 10 times faster than sklearn together with outlines. So it is continuing to growing, and we hope everyone who are running your agents could try that out. And we even have write a detailed documentation for the usage and somehow like the idea behind constraint decoding. Okay, so yeah, sharing something interesting. We have our open source map. Here you can see we have speculative decoding while trying to figure out how to do much more scalable and stabilized speculative decoding like Medusa and Eagle. And the second thing is post-training framework integration. It's somehow tricky. Like for inference engine, you may do not want to only use that in inference. In the process of RHF, you have a lot of time spending on rolling out. You have to do weight synchronize and to do weight process broadcasting. So I'm working on this part, and we are implementing sklearn into VRL and OpenRHF. And these kinds of sort of open source framework for RHF. Yeah, and we hope to boost the open source RHF frameworks to 1 or 2 years and to meet the somehow meet the industrial level. Yeah. And we also have DeepSeek model optimization. It will be discussed by Ke and last. And we also will do sequence and pipeline parallelism. This is particularly suitable for these kinds of clusters with poor connectivity. Also, we are doing the preview and decode disaggregation. This kind of thing maybe is not suitable for everyone to use, but together with this kind of preview and decode disaggregation, we can do better KV cache management, and it will give a really interesting space for optimization for our router. Yeah. And also, we are doing the hierarchy KV cache management. Say right now, we are only caching the KV cache on the GPU. Yeah. So you can imagine we can even cache that on CPU or even to SSD, and that will save a lot of money. Yeah, you know, the DeepSeek model, they are pretty cheap. That's how they achieve that partially, right? They are saving their KV cache on SSD, and we will also implement this. Yeah, so since it's pretty interesting, and these are just leading features. We also have multiple of these kinds of ongoing features and waiting for everyone to explore that, and hope you will submit new issues to us, and we really enjoy that. Yeah. And final thing, yeah. Sorry. Let me check. Yeah. Here's some of our community adoption, and it's be ranked by alphabetically. And you can see AMD XAI, Hyperbolic, Stanford, UC Berkeley XAI, and Common AI. Yeah. So if your company feel interested, and we are really happy to list that on this slides, right? And hope we will have more community users. Yeah, to the last point, here's something more. We have our Slack channel. If you have any question regarding serving engine, not only related to SGLang, but also related to some other thing like GPU acceleration, you can post your question on our platform. And we also have a bi-weekly development meeting. In this meeting, we will discuss the develop roadmap of SGLang, and also we will have some paper presentation. Like last week, we are the first to serve DeepSeek V3 model. So we also invited people to discuss about DeepSeek models technical reports. Yeah, so everything is not only related to SGLang. If you have interest in MLSYS and anything related to LM, please feel free to discuss with us. Yeah, and we also have a documentation that is fully written in Jupyter Notebook. I know a lot of you guys maybe have seen the documentation of other serving engines, but that's pure with Markdown and it is not compilable. But we have our documentation with Jupyter Notebook, so every line of the code can be reproducible, and we think that is better. And lastly, we have our learning materials about SGLang, and we also have sharing every slides we have in public. So checking out these links and this PPT will also be updated to the maybe to Hyperbolic's Twitter, right? Anyway, that's all I have discussed today. So it's time for question and answer. Yeah, thanks so much for your listening, and hope everyone have an AI night. And yeah, thanks. Oh, thanks.
Thank you. Very amazing presentation. I have a quick question. In the first part of this presentation, you mentioned that you can actually overlap the execution of the GPU task with the execution of GPU task. So I was wondering, compared to the traditional blocking scheduler, how much percentage can you how much performance gain can you get from this cheek?
Okay, actually the performance gain can be profiled with different stages. Like if you have something really long sequence and really a huge batch size, you know that the tokenization should be purely running on CPU, and that's not somehow like streaming. That could not be in the batch. So if you have that kind of thing, really long sequence and really huge batch size, it will be extremely easy to save for that. And in that case, I think it will be maybe 2 or 3 times better. But somehow on average, we can reach 1.2 or 1.1 times faster. And you can see this kinds of general optimization for any model is really difficult. And we have achieved that. Yeah, and that's the part. We also have a technical report for this, and you can see on our blog, like the LMSYS.org blog. Yeah, that is.
So
okay.
if the context window is pretty small, I mean, if the length of the input text is pretty small, then the performance gain from this trick is not that big, right?
I think it could also be visible, and you can try that on small models and also on these kinds of large distributed group. Like if you are running on TP size larger than 2 or larger than 4, it will be much more obvious for you to see. Yeah, you can try that out. Yeah,
sure. Thank you.
Yeah, thanks. Okay, thanks.
I have a quick question. So like fireworks together, they're like doing a crazy optimization on serving.
Yeah.
Like how you think, like how much do you think SGLang can have the similar performance as like this closed source company?
Yeah, we have to say, for inference engine, we think SGLang has met the closed source performance no more than 3 months performance leak. And the thing that for the firework engine, we are even better and DeepSeek model, and we have proven that. And maybe they are also discovering how can they make their engine better. And we are learning from each other. Yeah, and inference engine is a burgeon in place, and we are learning from a vast of community. Actually, we have learning from similar engines like the popular one, VLM, TurboMind, and this kind of element deploy, right? And we hope to see this kind of whole community will be better and better. But compared with open source RHF frameworks, I have to say that RHF framework is much more closed sourced. Each company has their own RHF pipeline, but they do not share that. So for LMSYS organ, our mission is that we want to boost this further. We want to give a somehow much better RHF framework for current usage, and hope everyone could run their RHF ideas and alignment ideas on our platform. And that's our mission. And we are really hoping to boost the open source language model research to a better place. Yeah, thanks.
I have another performance question. I'm kind of curious, for models running in SGLong, what attention and KV cache kernels do you typically use?
Sorry, what kinds of KV cache people use to?
What type of attention kernels and KV cache kernels do you typically use?
Okay, Byron, could you? Okay, for the attention backend, we are mostly using Flash Infer, and it's also a project under LMSYS organ, and it's yeah. And for the KV cache, most of the time we are running KV cache with our Redis cache, and we are the first one to present that idea. But right now it's just a standard for every inference engine. But we are also the best and the fastest to make that. Yeah.
Do you think you may adopt page detention like VLLM at some point, or?
We also have learned from them, and we really appreciate their ideas. Yeah, we are just collaborating and computing with each other. Yeah. Oh, okay. Which? Yeah. Thanks.
Thanks. I'm wondering that would you mind speak more about the post-training roadmap? Because I think it's the optimization mainly between like the different, like the Megatron and I think the weight with the S3 lane. And what do you want to achieve that? Because as I know, I think like the OpenRHF or something like that, I think it's integrated with like the VLM. And the VLM with like a DSP, the Megatron has a different format for the checkpointing. Yeah, so I am wondering like which kind of the like optimization you will do for the way thinking, and is there other kind of optimization for the inference engine for the post-training side?
Okay. You're asking the right person, since I have working on SGLang for RHF for more than half a year, right? So the thing that we are trying to facilitate open source RHF frameworks and somehow like an official way. A lot of people, they are writing their RHF frameworks and they have to manually modify some of the codes for VLM, like make it from single controller into FSPD and this kind of thing. But we want to make that officially. We have to provide APIs on our framework, and we want CIs to make sure it's 100% correct for everyone to use. Also, for OpenRHF specifically, we implement better with synchronized methods, even faster than VLM. Also not that visible to everyone, but you know that for inference for RHF framework pipeline, most of the time was spent on rolling out, right? And SGLang is rolling out faster than in OpenRHF, and that's I have proved. So we are supporting. But for VRL, the things could be much more complicated. We are implementing an FSPD framework rather than single controller, and we have do something like the memory release and say doing training, not the cache always occupying your GPU, right? You can somehow just release the memory of inference engine, and when you are doing inference again, you can rebuild that, and that's what we do on VRL. We hope that we can make a 7 billion those really on one H1 GPU. Right now, we are using open framework to run 7. You have to take more 3 and 1 to make that 1. Yeah.
I think most of the open source RHF frameworks that most of the default option is use a single GPU node. It will offload and load to the GPU.
Yeah. It's on one single node, but we hope to just using one GPU rather than one GPU. Say, and right now at least you should use 3 GPU on H100 to run OpenRHF. We are using one. Somehow like the if example.
Thanks.
What problem? I just move it. further. Okay, thanks. Yeah, are there any more questions? Thanks. Okay. Okay, so that's about SGLang serving for multimodality, right? So right now we have a small new country models and the source multimodality. The total is much larger than that is merged to make sure code quality is good to meet our standard. We are definitely building on this. And also looking ahead, we want to support SGLang for like the diffusion model serving. It's also regress. And also there's somehow like the, recent AI has launched their word model. And they are also discussing how to sing this word model with the person who is the first author of the word model. Hope to see that in the coming half a year. Yeah, thanks. Also, regarding like the linear attention model and multimodality model, we are also thinking about the linear attention model, right? You see, recently we have the Minimax the one model released, and they are the first best performed linear attention model and really catch everyone's eyes. So also trying to implement that and serving a member. They're serving a transformer since the KV cache is much more easier to control. Yeah. So we have a lot of things on our plan, and we are calling for more contributors. Right. If you have interest, please come. Yeah. Okay. Yeah.
Thank you, everyone. Maybe this is better. Yeah. So I'm inviting you over for a quick break before we have our next panelist coming from Poe by Quora, who's another partner of ours. In the meantime, since I mentioned to you before, I'm working in business and operations, and we're hiring at the moment, and so we're looking to hire two specific roles. The first one is AI systems engineer. So anyone who's actually, really good with serving frameworks like SGLang or, VLLM is obviously, open to come speak to me. And the second one we're hiring for right now is, a very passionate DevRel engineer is going to be working on really, really cool projects around AI agents. I think Jasper mentioned a little bit about this already, during his presentation. But yeah, this is one of the coolest projects that we have internally in terms of like our innovation team at Hyperbolic. So yeah, don't hesitate to come reach out. We have new, fresh pizzas that just came in. So enjoy for 10 minutes, and we'll go back to that. Thank you. Yeah. Thank you, everyone. We're gonna get started for our next panelist. We're very, very happy to have here Nick from Poe by Quora. So yeah, I'll leave the mic up to him.
Hi, everyone. All right, just a quick show of hands. How many people here have heard of Poe? All right, great. I see my colleagues raise their hand, which is good. So yeah, today I just want to give a brief overview of Poe, what we're all about, and I'll just give a brief demo of our platform for those who haven't heard of it. So I'm Nick. I lead AI partnerships for Poe. We are a platform. Oh, I can hear myself. That's a little weird. Okay. All right. Oh, is it this one? Hello, hello. Thank you. So Poe is a single platform where users can interact with all the latest AI frontier models across modalities. I still hear myself, but maybe it will go away. So on the text side, you have all of hello, hello. I think it's coming from the TV. I'm just gonna mute the TV. Hello, hello. There we go. That was it. Thank you. Thank you very much. So Poe is a single platform where you can, as user, interact with all the latest AI models across modalities. So we are partnered up with basically all of the major closed source labs, as well as have providers that provide all the latest open source models as well. So Hyperbolic's there, Grok's there, Fireworks together. So here's just like kind of our universe. So across text, you have the latest reasoning, DeepSeek, video, audio, and image. We've expanded considerably over the past quarter. We also have a really active creator ecosystem, which is actually what I want to spend most of my time on today. We want to be a place where AI creators and AI developers can create sustainable businesses, can reach users, can monetize and cover their inference costs, or more so. So on Poe, there's two kind of ways to stand up what we call a bot, which is how users interact with a model. One is a prompt bot, which doesn't require any coding. If you're technical, it's basically just tuning the system prompt for the models that support that. And then you have a server bot, which is a more general architecture where you can basically stand up whatever you want, like your world is your oyster, on your own hardware, and we'll basically pass user messages to you. In exchange, we will give you points, which is our form of creator monetization. So just here, you have like an example of like a fitness coach that someone made as a prompt bot. You also have more complex server bots. So like Llama's hosting, or sorry, Hyperbolic is hosting Llama 3.1 70B, etc. So if you're a developer, I think there's a lot of tools out there. I think you have to ask yourself, like, why would you want to develop on Poe? Our core idea is that we want to abstract away all the things that are common to AI applications so that you don't have to worry about that. So if you develop on Poe, you'll get support across all of our platforms, iOS, Windows, Android, and Windows Desktop. We handle all the authentication, sign up, user verification. You get internationalization out of the box, and you get distribution to millions of active users. So we're continually investing in discovery, so ways to make the best bots on our platforms bubble up to the top. And like I mentioned, monetization is really a core focus. So we have bots that are basically the top self-service creator is making more than $200,000 a year on Poe right now. A handful of others are making more than tens of thousands. Big providers are generating millions of dollars of API business for themselves. If you're a successful Poe bot, we've actually helped 2 companies on our platform raise millions of dollars through reference calls, and we have an active list of angel investors that want to opt into AI startups. And so happy to help you out on your journey there. I'll jump into a demo pretty quickly. Basically, you can go to creators.poe.com to see our entire protocol spec, how to stand up a server bot, I just want to highlight some exciting things that have come out in the past quarter. So one, and this will kind of make more sense in the demo, but one is what we call custom interfaces. And so there's a lot of like media generation models where you want to have like a lot of flags that you want to customize, styles. We make that really easy for users to tune, and soon creators will be able to use that. We have something pretty cool about bots, helping users to create other bots, which I'll demo. And then probably the last really cool thing is, LLMs have obviously gotten really good at being able to code. And so we have native like HTML rendering for LLM generated code in our product. So with all that, actually just want to jump into a demo and show you our product and what we've been working on. So, oh gosh, how am I going to do this? All right. I'm going to hold it like this, and you'll just forgive the awkward stand. No, how about this? There, much better. Okay, so this is po.com. This is the desktop. I guess like I could ask like the default bot like a simple question like, what are the most cost-effective AI inference providers? And I think one thing that's really important about Po as compared to like ChatGPT or Claude is we're model agnostic, we're provider agnostic. So if for whatever reason you don't like find this a satisfying answer, as maybe Jasper does not find, this is kind of stale. It's probably as of the knowledge cutoff of this model. In our product, we quickly make it easy to compare. So let's say I want to ask like, what does Grok say about this exact same question? They kind of have like another unsatisfying answer where they're talking about like the leading hyperscalers. This is actually a pre-baked example where I have a, don't worry, we'll see Hyperbolic show up very soon. So, this is like, of course, Grok beta is like has a knowledge cutoff and maybe doesn't have live information. Instead, I'll ask web search on Po, which is like a bot that does have access to the internet. And there, see now we have the right answer, right? So I think this is kind of like the text chat paradigm that we support. Just because I mentioned the creator's monetization, I want to show off one thing that might not be as obvious to just like a user who's using this casually. I'll do one more thing. I'll explicitly ask like Claude 3.5 Sonnet what they think of this. Just for the purpose of this demo, just ignore the answer, but I want to show you something after this streams. So if you go up, the way we manage costs and distribute payouts is based on usage. And so myself, this account is a subscriber. It gets 1 million points per month. I've used like 700,000 this month. And then every message will cost a user a certain number of points. So this first one that I sent to Assistant cost about 20 points. So that's like a flat price. Most API providers and like, because cost is a function of tokens in and tokens out, have to have variable price. So you can see here that like we break down the full cost from passing in the context. So some's from the chat history, some's from the message itself. And then like the answer was quite a bit longer than the input. So there was like, basically an equivalent amount of points for the tokens out. So that's kind of like the basic chat interface. I just want to ask like, could I get, let's do some image generation on some of these like awesome leading Flux family models. Could I get a animal from the audience? A frog? Okay, could I get a color also? Green. And could I get a location? Okay. Maybe more specific, where in San Francisco? Okay. I was probably a bit aggressive with that last one. I don't think it will be doing very good, but I think it'll get San Francisco fine. And just quickly, could I get one more animal? A fox. Okay, awesome. How many folks have heard of like Pika? Okay, so they're a leading, so pretty satisfying results, right? You said fox, right? Okay, so Pika is like a leading video gen model. Something that's unique to them is they have this concept called scene ingredients, where you can basically start from either a text prompt or an image prompt to generate a video, but you can also add specific images that you want to be in the video. So that's basically what I'll just quickly show off here. So what do we want? What do we want our frog and our fox to do? What kind of action do we want? Let's keep this safe for work, please. They fight. Okay, good, good. All right, so let's say, I think the fight has to take place in San Francisco, right? Of course. Let's see, what was that first one called? Frog. And then this is the custom interfaces thing I mentioned earlier. So if like your model has kind of complex parameters, before how it handled it is you'd have to have like all these dashes to say like hyper realistic photo or aspect ratio. We've simplified a lot of that to just like be drop downs, which is like much more intuitive. This will be available to third-party creators very soon, like in a matter of a few weeks. And the mode I need to use here is called ingredient mode, which is their scene ingredients API. So while this starts, this will just take a little bit. Can I also get just the name of a celebrity? Brad Pitt, okay. So I mentioned also that we have the ability for bots to create other bots. And could I just get a quick show of hands? How many people have heard, like, this is a pretty technical audience, so I assume most will have heard of this, but how many folks have heard of fine tuning? Okay, so most people. So just like for those maybe watching on Twitter or whatever, fine tuning is like, a lot of these models are very generally capable, but they're also kind of expensive. So fine tuning is a way to make them better at a certain task, but trade off some of the generalizability for lower cost. And so there's this cool feature that one of our third-party developers made on top of the Flux Dev image gen model, which is like in the same family as the one I just showed off. What it's going to do as I finally get through these like 8 to 10 images of Mr. Pitt is it will train a LoRa. So it will trigger like a LoRa training job. And then we're going to be able to make a bot that leverages that specific LoRa. This will take a little while longer, so we'll have to go back to our fox and our frog. But I want to kick this off. I think I just need a few more. All right, let me just do one more for good measure. Oh, he's a little younger here. That'll challenge the model. All right, this will take just a little bit. So let's go back to our video gen task. Okay, we're at 51%, almost there. So while this loads, I'll just show one more modality that we've supported recently. It'll be quite quick. I'll just go back to the chat we had earlier about AI inference. I don't know if you noticed this, but there is like this speak button. So basically, what this will do is this will trigger the 11 Labs API, and it'll just very quickly generate an audio file. I don't know if this stream supports audio. Oh, okay. That, I think, is a browser bug. That has never happened before. Maybe it's an interaction with the streaming software. So yeah, this works. I promise. Go to our site right now if you don't believe me. Basically, you can like change the voice. You can change the speed. It also might have been my gloves. But basically, it's just like text to speech that I promise works. Okay, let's go back and see. Oh, I didn't tell them to fight. Sorry about that. Okay, I think I forgot to put a prompt in. Sorry about that. So it's just cutting away. Why don't I get this generating? And if there's any questions, maybe that'd be like a good time, because this will just take a minute or two. You're talking about the, actually, yeah, could you repeat your question?
So you said that you're triggering a LoRa fine-tuning job using some other image of Brad, right? So I was wondering what type of model do you guys use under the hood?
Yeah, so it's a great question. So I think this just leverages like, or just kind of reinforces the fact that we have like an ecosystem. So this bot that I'm using right here is not made by, okay. So I guess that's a live demo thing. Okay, it didn't trigger this. Good. So this is actually made by a third party. The company Features and Labels. So I actually don't know. It's based on FluxDev, the Black Forest Labs image gen model. So maybe they have some kind of like fine tuning service. We want to integrate this with other fine tuning companies that are basically having fine tuning services. That's like the reason that we developed this. So I unfortunately don't know the answer to your question. Other questions? I think we have like, maybe a minute more.
For the audio generation, do you support here?
Oh, hi.
Hi. For the audio generation, do you support personalized audio generation? For example, like generate audio mimic myself.
Oh yeah, like voice cloning.
Yeah, voice
yeah,
cloning.
yeah. So we currently support like I think 50 11 Labs voices and maybe 100 Cartesia voices. Those are the two providers we have that have audio right now. We don't support voice cloning only because we have to figure out how to get the UX right. Like you have to kind of like upload a audio file of your voice, and as is in the product, like when you press this microphone icon, it's going to think that you're going to transcribe it. So like we could do it, and if you just like dragged an audio file, like it could do that, and that's one of the things we're thinking about with 11 and Cartesia, but it's just we haven't had time.
Okay. Another question is about this UI. How do I know which modality? For example, I want like image in, audio out. How do I change the UI so that I can control the input and output modality?
Yeah, that's a great question. I mean, right now we're basically using the chat paradigm and then kind of like using files to kind of cross the modality barrier. But I think like if we want native image in, like we, on mobile, for instance, you would need to have like a picker where you kind of like choose your photo. That's not supported right now, but it might be in the future.
Sure, thank you.
I think one more question would be great, and then we'll see the exciting conclusion.
Hi, thank you so much for using the creator program. Can you maybe talk more about what the monetization looks like and what are some product or bots are getting traction?
Yeah, great question. Thanks for asking that. So basically, we want to align our incentives as much as possible with creators. And so kind of our core idea is that anytime we get, okay, we have something. Anytime we have like a revenue generating activity, we want to pass that on. So there's two ways that you as a creator will earn payouts. One is whenever you are kind of the last model that someone interacts with, after which they subscribe on Poe. And you'll get like what we call like internally a bounty. I think it's like $60 or something if it's like a standard $20 a month plan. Don't quote me, the docs are online. And then the other is for consistent usage. So later you'll see when we create another bot, you'll set your price in points per message. Every time, like let's say you set 100 Poe points, and then you trigger like 10 messages for a month, you'll get 1,000, and then at the end of every month, you'll get a payout according to that. It'll become a little bit more obvious when we show how to make a bot, but thanks for that question. Okay, so let's see. Do they fight? I guess they verbally fight. Oh, okay, we got some action. All right. I was worried that it was just going to be a war of words. Oh no, this didn't work. I guess this is just like live demos. All right, so I have a backup in case this happened. So I promise this works. You should try it on the site. But in case I made a Katy Perry bot. And basically, if I go to, actually, let's do Zuckerberg. This is a tech audience, right? So this one is trained on Mark Zuckerberg. Let's say, let me get like a position and like a color of and an outfit. Black shirt and a Darth Vader. Are we going to be able to see his face?
No, like the third Star Wars one where he's got mask off.
Oh, like Darth Maul? Okay. Let's say, I'm going to change it a little bit, but I'll do like in a Jedi outfit with a green lightsaber. Okay, there you go. I'll just quickly show kind of like what her question was about like the monetization program, just to kind of reinforce it and make it a little bit more explicit. So like when you go to Poe and you make a bot, you choose the type. So this is like the most technical. A lot of these that I demoed were server bots, but if you're not technical and you just want to make a prompt bot, you go here. You can choose a name, an icon, a description. You can choose the base bot, and then you basically set the system instructions. And here is where you set your price. So you don't want to set like too high of a price that no one uses it, but not also too low that maybe it's not worth your time. So if you set something like maybe $10 per 1,000 messages, that would translate to 834 points. And then every time that you have a user message handled, you will get a payout at the end of the month.
Is the computation done on your platform, or is it going to be provided by the guy who creates these bots?
Yeah, great question. So if you're talking about a server bot, the inference is like on you. So you would have to use like Hyperbolic or whatever your own hardware, and then you'd want to bake that into the price that you basically charge users.
And there's also another type of bots whose inference that doesn't take on the user's prem, right?
Sorry, could you say it again?
You said that if it's a server bot, then the user or the guy who hosts these bots is responsible for doing the computation, right?
Sorry, I'm not understanding your question.
I mean, so you said that if this is a server bot,
Yeah.
then the person who published this bot is going to be responsible for making the inference compute, right?
Yeah, yeah.
And what about the other type of bots? Because
I see. Yeah. So a prompt bot is like hosted by Poe. Yeah. Yeah. All right. Thanks for your attention.
Hi. Where's my slide? No, not this. Yeah. Yes. Okay. Hi. Hello. I'm Byron, and I'm now working at LinkedIn. I'm also a committer in LMSYS org. So today the talk is gonna be quite technical. So it will mostly focus around the cache-aware load balancer in SGLand, and I will explain what that is. Okay, so let's talk about the problem in a common LLM inference engine. So on a single inference engine, we can schedule a request based on the prefix cache rate. So the requests tend to have higher cache rate, which means that we can fully utilize the prefix caching. But what if you scale up to multiple nodes, or when you are doing data parallelism, or you want to put a load balancer like Nginx in front of the engines, then it is actually not aware of prefix caching, and it can easily like route the request to a very low cache rate engine. So take this diagram as an example. So normally we use a round-robin load balancer provided by Nginx. And for example, we have 4 requests, and the first 2 have the same prefix, and the second 2 have the same prefix. But when a round-robin load balancer is doing the routing, it's actually like route the first one to the first worker and the second one to the second worker, which result in a very, very low cache rate. Okay, so how can we resolve the problem? Let's talk about the questions here. So the question is that how can we design a load balancer which is both cache aware and load balance? These two are actually contradicting, because cache aware means that you want to send a request to a higher cache rate worker, but in the same time, maybe you will lose a load balance, which means that you might overload one worker or underutilize the worker. So how can we strike a balance here is a very important problem. And the second one is that we want to also be fault tolerant and dynamically scalable, just like what is provided by Nginx. You should be able to recover if one worker suddenly went down, or if you want to add one worker or remove one worker based on the usage, you should be able to do it. So there are 4 requirements here. The first one is cache aware. The definition is that the requests are sent to the worker with higher cache rate. And you also want to be low balance. So workers are not overloaded or underloaded. And you also want to guarantee fault tolerance, which means that workers can be removed without affecting the overall availability. And at the end, you want to make sure that you can dynamically add or remove workers. Okay, so these 4 are actually pretty hard to achieve in the same time. And in the beginning, our SGLang team came out with the first idea, which is a pretty naive idea, is that we want to do ad hoc query. So when a request comes in, we can directly query the worker to see what is the current cache rate. But this is pretty accurate. Like we can get the actual real-time cache rate. But the problem is that the overhead is very, very high. For example, if the network bandwidth is not very high, then you will suffer from network bottleneck. Or if there are many, many workers, this solution is not scalable because you need to query n times, and n is the number of workers. Okay, so the problem is pretty obvious, and we also did some quick experiment to prove that it's actually not very efficient. And yeah, so the first one is that this is actually latency bottleneck because the query is actually on the critical path of the request. You cannot avoid it, or you cannot like overlap it. And the second one is that this is not scalable because when we have multiple workers, you will result in n times of the overhead. And so we proposed an idea which is called approximate tree. And the idea here is that on the load balancer, and so here I'll use the terms interchangeably. So I will call it router as well as load balancer. These 2 are the same thing. And the idea is that we want to construct a simulated Redux tree on the router, which are very, very similar to the actual Redux trees on the workers. And these 2 might have some small difference, but we can make sure these are tolerable. And the observation here is that actually the actual shape and the accuracy of the simulated tree is not that important. What really matters is that we want to make the right decision of the order of the cache rate among different workers, because our goal is to route the request to the highest cache rate worker. So the actual, as long as we can determine which one has the highest cache rate, the actual shape and accuracy of the simulated tree is not that important. Yeah. So here's the design of the approximate tree. The first characteristic is that this is tokenization free, which means that we directly store the character inside the tree instead of the token, which is pretty special because in a normal Redux tree, like in the SGLang Redux tree, we actually store the token ID in the tree. But here, because we only need to determine like how much portion, we only need to determine the cache rate. So storing either token or character actually produce the same cache rate. And storing character can save a lot of tokenization overhead, especially when we scale up to multiple workers. Okay. And the second characteristic is that instead of, for example, if we have n workers, then technically we have to store n similar approximate trees on the router, right? But actually we can merge them together into one big tree, which can make like the memory is more efficient and the query is also more time efficient. So instead of storing all the trees, we can merge them into one. And so let's talk about how do we update the approximate tree. So there are two updates, right? The first one is insertion, and the second one is eviction. And the insertion happens when a request is routed to a worker. So say, for example, if we decide the request is routed to worker 1, then on the router side, we insert the request as characters into the approximate tree 1. Yeah. And the eviction. So actually, we also spent some effort designing an eviction because technically we should like we want to make the approximate tree and the actual tree as close as possible, which means that we might need to do extra communication from the worker to the router when the eviction happens on the worker. But this is very time consuming and also high overhead. So we propose that we can actually do it lazily, which means that we do it only after a certain period. And by default, we're doing it like, I think every 15 seconds. So every 15 seconds, we will trim the tree, and the order is by least recently used leaves. So let's look at an example here. So for example, we have two users. And the first user came in with a request, prefix 1 plus prompt 1. And we decided this go to some workers. So we insert this prompt into the approximate tree. This is the approximate tree. Yeah. Okay. So after that, send another request, and we send it to, and we insert this request also into the approximate tree. So the node will split. Okay, this is pretty obvious. And then the second worker comes, and then it also we also dispatch the request to a worker, which means that we can add the worker into the approximate tree. And then the fourth request. Okay, so this is the insertion, pretty obvious. Like when you send a request, you add the request into the approximate tree as a character base. How about the eviction? So this is the approximate tree we just constructed. And we want to do a periodic eviction or garbage collection, as I just mentioned. So you can imagine a garbage collector will detect every certain period. And if the number of, actually this is character. If the number of character is larger than the maximum number of character, and this is returned from the worker because this is only returns once at the initialization, because the worker can calculate the memory and know exactly what is the maximum characters. Okay, so if we detect that we exceed the maximum character, then we start to do some pruning. And we prune the least recently used one. So we haven't touched it for a long time, so we remove it first. And then remove this, and then remove this. Yeah, and now the number of character is lower than maximum number of character, which means that we're safe. We don't need to do any garbage collection anymore. Hey. Say that again. Oh, yeah. So number of character is so in a radix tree, each node contains certain characters, right? So we just sum up all the nodes to see how many characters are there. Yeah, yeah. Okay. Then, and this is the full algorithm. The thing I just mentioned is only the green part. Is how we ensure the cache aware. So let's look at the green part first. So the policy is actually pretty intuitive. If the cache rate is high enough, we send to the highest hit rate worker. If this is not high enough, we don't do cache aware. We just send to the smallest tree to do load balancing. Okay, so we add this condition because if the cache rate is only like 5%, then there's no purpose for us to do cache aware routing. And the other important thing is that, for example, if you have a large data set which share the same prefix for all the requests, then if you merely use the cache aware routing, then all the requests will go into the same worker. This will cause a very serious overload. So we also want to make sure the load is balanced. And we do this by design a threshold-based load balancing, which is also pretty intuitive. So if the maximum load minus the minimum load is like exceeds the certain number, then we started then we select the last busy one to send it to it, so it can do some load balancing. Yeah, and this is actually a little bit more convoluted in practice, and I recommend you to look at our documentation. So, but the big idea is that we first detect if the router, if the current workload is low balance. If not low balance, then we send to the worker with the fewest running requests, which means that is the least busy one. And if this is balanced, then we can do cache aware routing. Yeah. And another critical thing to mention is that the whole router is written in Rust. And in the beginning, we tried to implement in Python, but it produced very significant overhead for merely just forwarding a request, because for load balancing, it's actually just forward the request to the right place. But in Python, we suspect it's mostly because of like GIL and some CPU overhead. So it introduced a lot of time. And Rust is very good at performance and also provide pretty good Python binding, so we can easily combine the Rust implementation with the current Python code of SGLang. And this is a benchmark. You can see that with the same implementation, both are under round-robin algorithm. You can see the Python is much slower than the Rust implementation. Yeah, the vertical asset is the time. And another feature we provide is dynamic scaling, which means that this is for actual production use, because when you deploy the router into a real production use case, you want to, for example, when the usage is very, very high, then you want to dynamically add more workers without shutting down the whole cluster. So we provide two APIs. The first one is add worker. You can use this to add a new worker into the cluster, or you can also remove the worker using remove worker API. And when we're doing the update in the cluster, we also maintain that this is like this is available, which means that it won't make the whole cluster down. We'll make sure that the transition is smooth. And we also support fault tolerance. So which means that if the big idea is that if a worker suddenly went down, then we will detect it and kick that out. So for example, and the policy is like this. So if a request was routed to a worker, but keep failing for a certain amount of time, then we will remove the worker from the router and move on to the next worker. So this can ensure the fault tolerance. So a quick summary here is that the cache-aware router was introduced in SGLang v 0.4. And before that, we are using round-robin data parallel. So after we have the cache-aware data parallel, you can see this is a router. And on the router, we have the approximatory that I just mentioned, and also the load balancing mechanism, and also fault tolerance and dynamic scaling. So with this, we can achieve much higher cache rate, especially for like long shared prefix workload, like multi-turn or like shared prefix data set. And without cache-aware routing, we are wasting a lot of compute resource on recompute the KV cache. So here's a quick benchmark for, and so this is the, we did this benchmark with simulated workload, and these two are the actual production workload. So you can see that in the original SGLang v 0.3, the cache rate was merely around 20%, and the throughput is around 80K. But with SGLang v4, the throughput essentially 2 times, and the cache rate increased from 20 to 75. And we also have multiple users adopting it in their production use case. So one user reported that the cache rate went from 25 to 70% when using Llama 37B on H100 with TP equals to 2. And another user reported that the cache rate improved from 25 to 75% for Llama 3AB on A100. And I think this is for shared prefix data set. So yeah, I'm from LinkedIn, and we have heavily invested in SGLang also. We use it not only for LLM, but also for some recommendation use case. And we have I think from last year, we have contributed multiple features, including the first one is we contributed HTTP-free SGLang engine, which means that you don't need to always have a HTTP server on top of SGLang engine. You can directly interact with the SGLang engine, which is more lower overhead. And we also contributed cache-aware load balancer. And most recently, we are building gRPC server, which is kind of an alternative of the HTTP server, which should produce much higher throughput than the HTTP protocol. Yeah, that's all. Hi.
So let's say that you have 2 workers.
Okay.
And they all have very high cache hit rate.
Yeah.
Let's say one is like 95%, the
Yeah.
other one is, let's say 90%.
Yes.
But worker 1 is currently heavily, loaded.
Okay.
But worker 2 is, it's just free.
Yeah.
So I was wondering, in this case, you said that you have a policy which says that if the cache rate hit is above a threshold, then it's going to discard the entire cache-aware routing.
Oh.
So in this case, is it going to lose the opportunity to route the sequence into worker 2, which also has a pretty high cache hit rate?
Okay, so your question is that if 2 workers both has pretty high cache rate, but one is overloaded and another is quite empty, and assume that maybe the overloaded one has higher cache rate.
Yeah.
Then how do we make sure the load balancing, right?
Exactly.
So this comes to this part. So when a request coming, it first go through whether the current router is low balance or not. And in this case, this is not balanced. So we will send to the worker with the fewer running request. So it will be sent to the empty one, even though it has lower cache rate.
But the question is, let's say that we have actually three, workers.
Uh.
Worker one, cache hit rate is 95, worker two 90, and worker three 0%. And let's say that worker one is, most busy, worker two is less busy than worker one, and worker three is completely empty. And this way, is the system going to send a request into, worker three, which has 0%, cache hit rate?
Yeah, good question. Good question. Yeah, it will send to the third request. This is not ideal
Exactly.
in this selection, but in a very long term, it will be amortized. Yeah.
How do you prove that?
So let's say that if you have a data set with some shared prefix, right? Then eventually you want to like spread the prefix to different workers. So making one mistake is actually tolerable for like online serving or a large data set.
Got you. That actually makes sense.
Yeah. Hi.
Hi, Byron. Thank you. That's the most in-depth presentation on load balancers I've ever experienced. But I learned a lot. So one specific question that I had, the design decision to remove the tokenization overhead, it doesn't seem like that would be directly relevant to the cache hit rate or to the throughput, but I'm sure there's, was that mostly for latency? I'm just curious.
Yeah, so you can look at this. So say if a request comes in, right? We first need to determine if this is load balance or not. And then we need to determine the cache rate. And then we need to insert the request into the tree. So which means that the insertion or even the eviction is actually on the critical path of the request. So we want to get rid of the tokenization because, for example, you have like 8 workers. And then if you do tokenization on the router, the tokenization is actually 8 times more than a single worker. And yeah, right, yeah. Because you don't want to do tokenization on a load balancer. Otherwise, you will do n times. And n is the number of worker you have. Yeah. Hi.
One question. Does where data parallel work with continuous batching? For example, in PyTorch, we could pack sequences and somehow, we could break requests. And up to the batch size, we could split the entire.
Do you mean if this is working with the continuous batching? Yeah. So this and continuous batching are actually like independent. The continuous batching happens on a worker, and this happens on a router. Yeah. So they can work together. Yeah. Hi.
We want to implement PD disaggregation in SGLM. What's your plan for further optimization of the router after PD disaggregation implemented? Yeah.
Good question. I'm not too familiar with PD disaggregation yet, but yeah, I'll try to look into that.
Okay, and good news is that a lot of people is connecting me through LinkedIn and asking about router, and they want to contribute together with you. So maybe later we can discuss that. Yeah.
Okay.
And
perfect.
congratulations.
Yeah. And actually, more and more people are using it. Thank you. Thank you.
Thank you, everyone. Yeah, so We just need 5 minutes for our last speaker of the night. So just gonna ask you to be waiting just 5 minutes patiently. Thank you so much. for our last speaker. Okay, I think we're connected, so I'll leave it up to Kay.
View of the computation process. and the memory access are more balanced.
Nice talk. Are there any questions?